Okay, welcome to 9.3, which is the law of sines. So I was planning originally to combine the law of sines and the law of cosines into one video, but I don't want to. So this is something new, kinda, called the law of sines or the sine rule, as it's known in UK and Australia, called the sine rule. So what it says is so the sine of the angle of the opposite to the side, the ratio of the side to the sine of the angle that's opposite to the side is equal to are equal in a triangle, basically. So sine A over A equals sine B over B equals sine C over C, or the other way around. And whenever we're using small, like capital and lowercase like this, you should know that they are opposite of each other. They're opposites of each other, right? And the angle is opposite of the side. And I'm gonna show you why it makes sense. I won't go through the proof because it will take pretty long to go through the proof. So I'm not going to show you the proof. However, I'll show you why it makes sense. So whenever you have this triangle right here, let's say we have this triangle, right? You can note, actually, no, let's say we'll have an exaggerated triangle. Exaggerated triangle. We have like this. You can note that this angle is obviously the biggest one. This is not less obviously the smallest one, and this is the second smallest, right? So this is a little less obvious, but that's the biggest, that's the second, that's the smallest, and that's the second smallest. And it's because of the ratios of the sides and the unit circle. Basically, if this right here was, let's say, 80 degrees, no, if this right here, let's say 60 degrees, we would have the sine about right here, right? The sine would be about right here. So the sine value would be pretty high. It will be pretty high. If we have this 60 degrees, this angle is obviously not 60 degrees, it's about 30. But the sine value will be pretty high if this was 60 degrees. If this was, let's say, let's say this is 100 and 110. If you see 110 degrees in the unit circle, it's even higher than the 60 degrees. See, and let's say this is 10. If you see the 10, you could see that it's really low. It's really low on the sine, on the height of the unit circle. So this 10 degrees actually has a really low, really small side, because sine of 10 is just that much smaller than sine of 60 or sine of 110. So sine of 110 is the biggest, then sine of 60, then sine of 10. And that's what explains the side ratios. And we're going to learn today that the side ratios are equal as well, not just of that relationship of the biggest, right? The bigger relationship. We're going to learn that they're equal, and this is the formula to prove that. Now we're also going to learn to do the area of the triangle, and I'm actually going to reprove this. So let's say we have a triangle with the exact same setup. So we'll have this triangle right here, A, B, C, A, B, C, and then we'll drop a height down here because that's how you calculate the area of a triangle. Let's say the height's H, right? So what we're trying to figure out is the height. However, we don't have anything to, we don't have the height, that we can just say the area is equal to HA, but that's boring, right? Let's use an angle. Let's use C. We're gonna use C as theta. So we're talking about sine, but you could just use a tangent. That'll kind of work as well. Although sines are just better. So sine is equal to H over sine theta is equal to H over B, right? H over B, because opposite over hypotenuse. So what's theta? Theta, no. So what's the height? That's what we're trying to find. The height is just obtained by multiplying B on both sides, and then you'll have b sine theta is equal to height. So now we can already find out that the height is just b times the sine of theta, and that's literally it, right? It's pretty cool. So if you want to find the height of this side, it's c times the sine of this theta. So c times the sine of this theta, or b times the sine of this theta, is equal to the height. And how we want to find the area of the triangle. So height is b sine theta. We have b sine theta times a, because b sine theta times a, and then you put a 1/2 in the beginning, and then that'll get you the area. So we can clean this up by putting 1/2 a times b, and then the sine of theta, and that is our area of the triangle formula. I don't think we're going to be doing a lot of this in the thing, though. I'm going to put more problems on the next one. So this is a little bit iffy. I shouldn't have shown you this like this early, but on the problems that you're going to be seeing, you're going to be given an angle and two sides. An angle and two sides. So for example, if the angle is A, if the angle is 120 degrees, you might be given sides 2.5 centimeters and 3.8 centimeters. Right? Let's say you're given those sides. And so if the A is 120 degrees and you were given those two sides, you could use that information to decide whether it is possible to make a triangle or whether it is not possible to make a triangle. So for example, in this case, we'll have 120 degrees, 2.5, 3.8. It looks like it's possible to make a triangle because the value of the value of 2.5 and 3.8, one of them is bigger than the other, so you can make that triangle. That's assuming you don't have like a C. And then if you solve the triangle, then you will be able to find all the other sides and all the other angles. But we're not going to talk about that yet. Actually, no, we are going to talk about that because we're going to go to the next section where we're going to solve for triangles using the laws of sine. So by 4s from 20, this is what I wrote down, just to say that we're going to be doing 20 plus 4 plus 4 and plus 4. So we have this triangle right here. This is 25, and this is 16, and this is 104. I'm not going to redraw a triangle. That's just a mess. So we have two sides, and we have one angle, right? So this is we have our two sides. We have our one angle. We can put as an equality of sine 104 degrees over 25 is equal to sine of whatever degrees, I don't know what the degrees is, over 16. So we can solve for the sine, solve for the x, which is sine inverse of 16 over 25 times the sine of 104 degrees, which will give you, that's a big number. So this is x degrees. I will use my phone to find the sine of this angle. So you will have 0.64 times the 104 sine. I think this is in degrees. Degrees. Okay, I need to be in degrees. So 16 divided by 25 multiplied by 104 sine is equal to 62, and then I want to find the inverse sine of that. I don't know how I'm supposed to do that. Let me see. Okay, I'll just go on the internet. Inverse sine of 6.21. Arc sine 6.21. Well, 0.621. Arc sine of 0.621 is about 0.67 radians. So x is roughly 0.67 radians, which is a total of roughly around 39 degrees, right? Roughly 39 degrees. So let's continue on to this triangle. This triangle is nice because this is 24 and this is 66, and it draws exactly for you to have a right angle. So therefore, you don't even need to actually use any of the angles things, right? Okay, so for this one, I haven't actually solved the whole triangle yet. This is 39 though, so then we can know that this is 37.
Yeah,
and then this is roughly going to be about 15.6 or something like that, because we gotta have the equal proportions. So we have this as our 90 degrees, and this is really nice because there is a 90 degrees. We can just use our sines and cosines just for like regularly. We can just do sine of 24, and I'm not gonna solve this because I frankly don't need to. So sine of 24 is equal to opposite over hypotenuse, so 43 sine of 24 is equal to b. Right, we can already find it. And since it's a co-function, we can just say 43 cosine of 24 is equal to a. Right, this is a co-function identity. So cosine of 60, sine of 66 is the same thing as cosine of 24. And that is our b and our a for this one. Next, we have b equal 5, c equal 5. So that's an isosceles. That means there will only be one solution. Because if you look back at this one, b equal 5, well, b and a is equal to each other. There's only one solution. And it makes sense. Because if there's another solution, it will be if there's no way it can be another solution because there are already two angles that have the same measure, right? So that's 5. That's 5. And this c right here is 26, right? So this c is 26. We know this c is also 26 because it's isosceles. And then right, this is c and this is b. So this is c, this is b, and this is a. The a is 180 minus 26, which is minus 52, which is 128. So what we're trying to figure out is 5 over the sine of 26 is equal to a over sine of 128. And the answer is just going to be 5 of sine 128 over the sine of 26. And that is the answer. I'm not going to calculate it out. It's probably, actually, you know what? I'll calculate it out. I'll spend some time on it. 128, the sine of that is that, and then times that by 5, you'll get that, and then divided by the sine of 26, which will give you about 8.98. So A is roughly 8.98. Okay, so now we have B is 10 degrees, B is 6, and C is 6.5. I'll go ahead and draw that. Let me just erase everything first. If you didn't catch it, just go back to the video and catch it. And then we'll have this B equal 10 degrees, B equals 6. That's gonna be a really big. That's a 6, and that's a 10 degree, and that's B, and that's B, and the C is 6.5. So I don't know. Okay, that's 6.5. Let's say. So we have that as a 10. We have that as a 6.5, and then we have a 6. So let's try to solve it. It probably doesn't look like this, but whatever. Let's try to solve it. So we have 6.5. 6 over sine 10 is equal to 6.5 over sine x. So in order to get our sine x, we can just flip this. In order to get our sine x, we have to do 6.5 times the sine 10 over the 6. That'll get us our sine x. So our sine x is going to be I can take the sine inverse of this to get x. So I'm gonna have to do some of the 6.5 times sine 10 degrees, and then what else? Divide by 6. Divide by 6. And then you take the sine inverse of that. Okay, so I hope Google works. And in the meantime, actually no, Google works. So 0.1881188. So we take the inverse sine of arc sine of 0.1881188. The inverse sine is also called the arc sine. That will give us about 0.189 radians. So 0.189 radians, which is roughly around 11 degrees. 11 degrees. So the this angle right here is roughly around 11 degrees, and which means this angle will have to be roughly around 159 degrees. So we can do our equality again. We'll have sine 10 over 6 is equal to sine of the 159 degrees over x. So our final equality is 6 times the sine of 159 over the sine of 10 will give us x. And that is it for the 4 problems that we have. We have more problems. You thought we were done? No, we're not. Okay, you are on the observation deck of the Empire State Building. So let's say this is the Empire State Building E. And then you're looking at the Chrysler building. So this is U right now. So U, right? Chrysler building. So this is what you're looking at. And when you turn 145 degree clockwise, actually this is a really bad clockwise. So when you turn 145 degrees clockwise, this is where you're gonna end up. You see the Statue of Liberty. So this is 145 degrees, right? And then you know that the Chrysler building and the Empire State Building are about 0.6, and the Chrysler building and the Statue of Liberty is about 5.6. So you have to estimate the difference between the distance between the Empire State Building and the Statue of Liberty. So Empire State and Statue of Liberty. So what can we do? We can use the law of sines. We can do the 5.6 over the sine of 145 is equal to 0.6 over sine of x. And I made a mistake again because I'm not supposed to have it have the x at the bottom. So I'm just gonna flip it quickly and do 0.6 sine of 145 over 5.6, and you take the sine inverse of this. So sine inverse of 0.6, 0.6 sine of 145 times 5 over 5.6. So I will do that real quick. 0.6. Oh god, I'm sorry, something came up. Okay, 0.6 sine of 145 degrees over 5.6. And then, okay, I hope Google works. No, if Google doesn't work, we'll go to question 6. Okay, I'll go back to question 5 later. Once Google works, I'll go back to question 6. So, question 6. Can you use the law of sines to solve this triangle? Right? Can you use the law of sines to solve this triangle? I'll let you think about it. I'm gonna go back to question 5 now because Google is working. So it'll be 0.06145, and now we're gonna take the sine inverse arc sine of 0.06145. Arc sine of 0.06145 will get you roughly, I think, a really low number, like 10 degrees. 0.06 radians, which is roughly around. So this is about 0.06 radians. Where is it? 0.06 radians. Which is roughly around, so 57, about 3 degrees. It's about 3 degrees, right? It's really not. It's not that. It's not that wide of an angle. So this is 32 degrees. You can figure that out already, right? The picture is bad, right? So you know, the picture is bad. So what 32 degrees in this direction. So now we can set the same equality. This time you have to put the x on the top. So x over the sine of 32 is equal to, and you can leave it in the exact form, right? Leaving in the exact form is actually pretty good. but you also should know how to calculate these by degrees, not by radians. And what you also have to know how to calculate it by radians as well. So this is your final answer for x. Right, this is the distance between the Empire State Building and the Statue of Liberty. So, if you thought about our previous question, the answer to this question is no. You cannot solve this using the law of sines. And the reason why we can't solve this using the law of sines is we have two sides and an angle. This is unknown, and this is unknown. So basically, sine C over C. This is unknown. We don't know this, so don't know. I'm just gonna label all the don't knows with red, and that's equal to 8 over, or sine B over, which we don't know sine B, so I'm gonna label that red. We don't know sine B. Neither do we know sine A, so I'm gonna put sine A as well, right? So this is all unknown, right? These are all unknown. However, with some other crazy manipulation, you can turn the law of sine formula into the law of cosines formula, which is what we will be doing next, a law of cosines or cosine rule. And that concludes the lesson for 9.3. I'll see you next time.